Time travel, a dream or reality? We humans have always been fascinated by time. From the moment we wake up to the time we go to bed, our lives are governed by the ticking of the clock. We set alarms to wake up, schedule meetings, and even count down to special events. Time is an integral part of our existence. We measure its passing, celebrate its milestones, and even dream of traveling through it. Think about it: New Year's Eve, birthdays, anniversaries. These are all moments where we acknowledge the passage of time. We look back at old photographs and reminisce about the past, wondering what it would be like to revisit those moments. But what if I told you that time travel isn't just science fiction? Imagine being able to go back and witness historical events or leap forward to see what the future holds. It's a concept that has captivated our imaginations for centuries, from H.G. Wells' The Time Machine to modern-day movies and TV shows. It's a real phenomenon, and it's called time dilation. This isn't just a theory, it's a proven scientific fact. Time dilation occurs when time itself is stretched or compressed, depending on certain conditions. It's a mind-bending concept that challenges our everyday understanding of time. Time dilation means that time is not constant. It can vary based on speed and gravity. For instance, the faster you move, the slower time passes for you relative to someone who is stationary. Similarly, the stronger the gravitational field you're in, the slower time moves. This has been confirmed through various experiments and observations. It can speed up or slow down depending on how fast you're moving or how strong gravity is around you. Sounds crazy, right? But it's true. Imagine flying in a jet at high speeds or being near a massive object like a black hole. In both scenarios, time would behave differently for you compared to someone on Earth. And it's all thanks to Einstein's theory of relativity. Albert Einstein revolutionized our understanding of time and space with his groundbreaking theories. His famous equation, E=mc², laid the foundation for modern physics and opened up new possibilities for understanding the universe. Stick with me as we delve into the mind-bending world of relativity and discover how time dilation might just hold the key to unlocking the secrets of time travel. We'll explore the science behind it, look at real-world examples, and ponder the possibilities of what the future might hold. Are you ready to take this journey through time? Albert Einstein, a genius who changed the way we see the universe, revolutionized our understanding of space, time, and energy. His contributions to science are monumental, but perhaps his most famous work is the theory of relativity. This theory isn't just a set of complex equations, it's like a rulebook for how space and time work. It fundamentally altered the way we perceive the fabric of our universe. Before Einstein, people thought of time as a constant, unchanging flow, much like a ticking clock that marches forward uniformly. But relativity says that time is not like a rigid ruler, the same for everyone. Instead, it's flexible and can stretch or compress depending on various factors. Imagine a ruler that bends and twists. That's how time behaves according to Einstein's theory. It's more like a flowing river, changing speed depending on gravity and motion. Just as a river's current can speed up or slow down, time can flow differently in different situations. For instance, near a massive object like a planet or a star, time actually slows down. Imagine two people with clocks. One is standing still, the other is on a super-fast spaceship. According to Einstein's theory, the person on the spaceship will experience time differently than the person standing still. Einstein's theory says the person on the spaceship will see their clock ticking normally. To them, nothing seems out of the ordinary. Their seconds, minutes, and hours pass just as they would expect, but they'll see the clock of the person standing still ticking slower. This phenomenon is known as time dilation. It's a mind-bending concept, but it's been proven through various experiments and observations. This is because the faster you move, the slower time goes for you relative to someone standing still. This effect becomes more pronounced as you approach the speed of light. So, in a way, Einstein showed us that time is not an absolute but a relative concept, intertwined with the very fabric of space itself. Think of time as a river. You can float along gently in a calm section, or you can hit the rapids where the water rushes you downstream faster. Time dilation because of speed is like hitting those rapids. The faster you move through space, the faster you're moving through time relative to someone standing still. But here's where it gets really interesting. Time dilation also happens because of gravity. Let's imagine we have two identical clocks, one on Earth and one on a spaceship traveling at near light speed. As the spaceship speeds away, something fascinating happens. Time on the spaceship actually slows down compared to time on Earth. This isn't just a trick of perception, it's a real phenomenon. If the astronauts on the spaceship were to return to Earth after a long journey, they would have aged less than the people they left behind. This is because they experience time at a slower rate due to their incredible speed. Section 5. Gravity's pull times master. Just like speed affects time, so does gravity. The stronger the gravitational pull, the slower time moves. Imagine, if you will, a giant bowling ball placed on a trampoline. The bowling ball represents a massive object like a planet or a star, and the trampoline represents space-time. The heavier the object, the more it warps space-time, and the slower time moves in its vicinity. Section 6. Atomic clocks. Proof is in the ticking. You might be thinking, this is all very theoretical. Is there any proof that time dilation is real? The answer is a resounding yes. Scientists have conducted experiments using incredibly precise atomic clocks to measure time dilation. They placed one clock on a jet plane and another on the ground. After the plane had circled the globe, they compared the two clocks. Guess what? The clock that had been on the plane showed a slightly earlier time, proving that time had moved slower for it due to its motion. Section 7. So, can we time travel? Time dilation might make time travel possible, but not like in movies. In the realm of science fiction, time travel often involves hopping into a machine and instantly appearing in a different era. However, the reality is far more complex and intriguing. Time dilation, a concept rooted in Einstein's theory of relativity, suggests that time can be stretched or compressed, depending on how fast you're moving relative to something else. This means that if you were to travel at speeds close to the speed of light, time would pass differently for you compared to someone who stayed on Earth. Traveling to the future is what seems doable. Imagine boarding a spacecraft capable of reaching near light speeds. As you accelerate, time would slow down for you relative to those on Earth. This phenomenon, known as time dilation, has been confirmed through various experiments such as observing particles that decay slower when moving at high velocities. So, in theory, you could travel for what feels like a few years to you, but when you return, decades or even centuries might have passed on Earth. If we could travel near the speed of light, time would slow down for us relative to Earth. This isn't just a wild theory, it's a well-documented effect of special relativity. Astronauts on the International Space Station experience time slightly slower than we do on Earth, although the difference is minuscule due to their relatively low speeds. But if we could achieve a significant fraction of light speed, the effect would be much more pronounced. We could return to Earth years, decades, or even centuries in the future, effectively traveling to the future. This kind of time travel doesn't require any exotic technology, just the ability to travel extremely fast. However, the engineering challenges are immense. Building a spacecraft that can sustain such speeds and protect its occupants from the harsh conditions of space is a monumental task. However, traveling to the past is a much trickier concept. The idea of reversing time brings up numerous paradoxes and complications. For instance, the famous grandfather paradox questions what would happen if you went back in time and prevented your grandparents from meeting. Would you cease to exist? These kinds of questions make backward time travel a highly debated topic among physicists. While time dilation is a fascinating phenomenon, it doesn't give us a way to rewind time. The laws of physics, as we currently understand them, don't allow for backward time travel. Wormholes and other exotic solutions have been proposed, but they remain purely theoretical and face significant scientific and practical hurdles. The laws of physics, as we currently understand them, seem to prevent going back in time. So, while the idea of visiting the past remains a tantalizing dream, our best bet for now is to focus on the future. With advancements in technology and a deeper understanding of the universe, who knows what possibilities might unfold. Section 8. Time dilation in the universe. Black holes and beyond. Time dilation isn't just a theoretical concept, it plays a crucial role in our understanding of the universe. Black holes, for example, are regions of extreme gravity where time dilation is taken to its most extreme limits. At the event horizon of a black hole, time essentially stands still, relative to an outside observer. This means that if you were to fall into a black hole, you would experience time infinitely slowing down as you approach the singularity at its center, while an outside observer would see you frozen in time forever. Section 9. The importance of time, unlocking the secrets of the cosmos. Understanding time dilation is crucial for our understanding of the universe. It affects everything from the GPS satellites that guide our cars to the behavior of stars and galaxies. By studying time dilation, we can unlock the secrets of the cosmos and gain a deeper understanding of the fundamental laws of physics. Who knows what other mind-bending discoveries await us as we continue to explore the nature of time? Perhaps one day, time dilation will even allow us to achieve what was once thought impossible, traveling to the stars.